Hello everybody. We're going to be evaluating an integral using trigonometric substitution today. So let's take a look at our integral. We have an integral of x squared all over 4 minus x squared to the 3/2 power. We can see this 4 minus x squared. This is sort of a cue that trig substitution might be a good idea. So the recommended substitution in this case is going to be x is equal to 2 times sine of theta. If x is equal to 2 times sine of theta, that means dx is going to be 2 times cosine of theta, d theta. And let's go ahead and continue onwards. So from here, let's just take all of this and put it into the integral. That x squared turns into a 4 times sine squared. The 4 minus x squared in the denominator turns into a 4 minus 4 sine squared theta, and this is all to the 3/2 power. The d theta, or the dx, turns into a 2 times cosine of theta d theta. So there we go. We have all of the pieces put in, and now we need to start simplifying. We already know something's going to happen down here with this 4 minus 4 sine of theta. So an easy way to see this, we'll just write the rest of it down. So we can factor a 4 out, and after we factor a 4 out, we're left with a 1 minus sine squared. This is one of those common Pythagorean identities that we want to remember. Okay, so this is one of those common Pythagorean identities we want to remember. We know that 1 minus sine squared is equal to cosine squared. And so what we really have here is, I'll go ahead and I'll multiply the 4 and the 2 together here to get me a total of 8 on the top. We have sine squared of theta, cosine of theta, all on the top here. In the denominator, we have a 4 times cosine squared of theta, all of this to the 3/2 power. Now, a lot of students are thrown by this 3/2 power. Don't let it bother you. We are applying the 3/2 power to both the 4 and the cosine squared. So we'll just rewrite the numerator here, 8 times sine squared of theta, cosine of theta, d theta. In the denominator, we're going to apply the 3/2 power to the 4. So the square root of 4 is going to be 2, to the 3rd power is going to be 8. And the square root of cosine squared is cosine, to the 3rd power is going to be cosine cubed. And there we go. So this is already looking quite a bit better. Let's continue to simplify. We have 8 sine squared cosine on the top, and we have 8 cosine cubed on the bottom. The 8's can go, of course. We have a cosine on the top that we can cancel with one of the cosines on the bottom. Excuse me. So what we're really left with here is just a sine squared over cosine squared. And so right now there's a whole lot of thoughts that could run through our head. A lot of them will be very productive, but one that we happen to remember that sine over cosine is equal to tangent. This is not the only way to do the problem, but it's just the way we happen to see. So this is really tangent squared of theta d theta. And one of the really nice things we know about tangent squared is through that Pythagorean identity, it's really closely related to secant squared. And secant squared is a very nice antiderivative. So tangent squared is secant squared of theta minus 1. So this is a tricky one to see sometimes, but when we can use it, we should. So we know what the antiderivative of secant is. The antiderivative of secant is tangent. So we have tangent of theta. We know what the antiderivative of 1 is. Just theta. And of course we have the plus c. We've just done the antiderivative, and so the hard part's over. We now need to just replace the variable theta with the variable x. The problem is we can't directly do that with our original substitution. So what we need to do is we need to make a triangle with the appropriate side lengths in order to get this done. So we're going to make a triangle with angle theta and ask ourselves, what should the triangle side lengths be if I want x to be equal to 2 times sine of theta? Well, sine is opposite over hypotenuse, so this is going to be x over 2, right? That's sine. This means the remaining side here is going to be 4 minus x squared. And we can see that 4 minus x squared sitting in the original problem. So this is sort of a reassuring thing. Alright, so let's keep going here. We need to know what tangent of theta is. Not a problem. We hop up here to our triangle, and tangent is opposite over hypotenuse. So tangent of theta is just x all divided by the square root of 4 minus x squared. And then we also need to know what theta is. Well, that's not a problem either. We know that x is equal to 2 times sine of theta. That means, let's just draw this in a box on the side, that means that x over 2 is equal to sine of theta. And if we apply arc sine to both sides, we know that arc sine of x over 2 is equal to theta, which is what we'll write here. So there we go. We've replaced tangent of theta with x over square root of 4 plus x squared, and we've replaced the theta with the arc sine of x over 2, and in doing so we've translated the problem from a variable theta to a variable x. And we're done. We've done the antiderivative, we translated back to x. We've needed to use this triangle here, but that's pretty common for most of our trig identity problems, or most of our trig substitution problems, sorry. So this is a fairly standard trig substitution problem, as standard as these things get. There's a little bit of cleverness here in seeing that we have a tangent squared, which is a very handy trig identity, but otherwise this thing is as straightforward as these come. Anyway, if you have questions on these or problems like it, please let me know, ask me in class. I'm happy to help out. Anyway, good luck and happy mathing.